Welcome. Thank you for attending the 2021 Myosha Trench Safety Stand-Down event. I am Jeremy Hidalgo, Supervisor with the Construction Enforcement Division, and will be the facilitator of today's event. This presentation is being recorded and will be available on our Myosha Trenching website. In a few minutes, we will hear answers from industry professionals on common excavation questions. Hopefully, these upcoming questions and answers will provide clarity and further discussion about working safely in excavations. Here's a quick fact regarding Myosha enforcement for excavations. Between 2018 and 2020, Myosha conducted 147 inspections of excavations, with 4 being fatalities. These inspections resulted in 130 serious citations, 9 repeat citations, and 31 other than serious citations, with initial penalties totaling $294,140. Nationally, 58 employees were killed during the same period. Why should we do a stand-down event for trench safety? We do proactive events like this to provide talking points for companies on safety and job site awareness because we feel injuries and fatalities can be prevented. We know working in and around trenches continues to be a high hazard profession, and we do not want anyone else killed or injured. Trench fatalities can happen on large industrial settings, commercial, or even residential projects. Knowing how to protect employees working in excavations is important because surviving a cave-in has very low odds. Most cave-ins happen without warning signs, and with 1 cubic yard of dirt weighing approximately 3,000 pounds, none of us would be able to escape. Myosha and industry safety professionals, like those participating today and others throughout the state, continue to provide training and instructions to companies regarding compliance with Part 9 excavations, trenching, and shoring. Because of the nature of working in an excavation, it is imperative companies provide training to their employees during all phases of the operation. Employers should provide multiple ways to train their employees about trench operations. Some training operations are classroom, internet, and on the job. Depending on the type of trench, employers could also choose alternative methods of non-excavating to complete the job. 2 such methods are directional boring and cured in place pipe. Both options do not require an open excavation, thereby eliminating hazards to the employees. Employers should have at minimum an accident prevention program or safety program with trench safety information. However, best practices for companies is to develop an emergency action plan for trench safety. Some action plan items to include are who is the qualified person, misdig information, water removal scenarios, atmosphere testing, and entry and exit information. All employees should review the action plan every day before work begins. Action plan review, along with ongoing discussions on how to identify the proper safety equipment for each type of excavation and what to do, who to call if the proper equipment is not available, will help eliminate unnecessary exposures, injuries, or possible fatalities. Also, have discussions on what safety areas were missed during the work operation. Keeping this review discussion positive can be a good starting point for your next trench project, and by tracking what safety areas were missed, it should help reinforce the correct safety practices your company is striving to achieve. Now I'd like to introduce our discussion panel. Sherry Scott is the manager for Myosha Construction Education and Training Division. She will be narrating the questions that have been gathered. Tracy Alfonsi is representing Construction Association of Michigan. Greg Brooks is representing Michigan Infrastructure and Transportation Association. Will Pitlack from Apex Septic and Excavating is representing Home Builders Association of Michigan. Chris Smith from First Companies is representing Associated Builders and Contractors of Michigan, and Paul Rosinski from Associated General Contractors. Sherry, are you ready to get us started?
Yes, I am. And Jeremy, you're first on deck with our questions. Question 1. My company mainly does excavation work. What MIOSHA standards besides Part 9 apply to safety on excavation jobs?
Well, as you know, MIOSHA has several safety standards to protect employees while working on construction sites. In the past couple of years, the standards most cited by our officers on excavation jobs besides Part 9 are Part 1 General Rules, Part 11 Ladders, Part 19 Tools, Part 6 PPE, Part 17 Electrical Installation, Part 18 Fire Protection, Part 13 Mobile Equipment, Part 15 Excavators, and then finally Part 22 Signs, Signals, and Barricades, which will send you to Part 6 for Michigan Manual on Uniform Traffic Control Devices, or the MMUTCD, for how to set up and work when exposed to traffic. Again, these are just some of the standards, as each job site is different, so ultimately the employer needs to determine the applicability of other standards into their working environment.
Thank you very much, Jeremy. Our next question will go to Mr. Paul Rosinski. Paul, are you with us?
Hello, Sherry. Yes, I am.
Okay, fantastic. So, Paul, the people want to know, how do I locate underground utilities?
Okay, well, thank you, Sherry, for that question. And there's really it's a 5-step process. And first and foremost, what we really need to do is look at MISDIG, or contact MISDIG. So MISDIG operates under Public Act 174, and most or all of the member utility owners are required to participate in a positive response program. It uses an electronic ticket system for confirming and that locating and marking has been completed. Once you do that, the tool really collects information from utility owners as to the locating status of the ticket, and any excavators can use the positive response to verify that their ticket has been marked, and if any other of the utilities have yet to respond. So it's usually a 3-day wait process. And then before excavating, the standard and not only the MIOSHA standard, but the MISDIG standard does say that you have to expose all of those marked utilities that are within what's considered a caution zone by either hand or soft excavating. And that caution zone is parallel to a utility. So hand exposing has to be performed prior to the use of the power equipment in that caution zone. And that means that caution zone is established within about 48 inches of either side of the utility. So there's a lot of different ways, or a couple different ways there. So by looking at that caution zone, and if there is no other visible evidence of a utility exists, then the power equipment can be used in what's considered a safe zone. And that safe zone means an area of 48 inches or more from either side of the utility marks.
Okay,
And
well,
then once you've established the locations, then you can make sure that you respect where the markings are, and then just use caution when you're digging, as always.
I'd like to add one thing to that, and I do appreciate the answer that you had there, Paul. Because you did mention about MISDIG, I would like to mention that MISDIG does offer free training for employers, and it's easy to find. You just go to misdig811.org. You click on their education tab at the top, and then you click on their training tab, and you can go through their free training that they offer.
Thank you, Jeremy, for the additional information. Our third question will go to Will Pitlack. Will, are you with us?
I am, thank you.
Okay, now the question that we have for you is, what is a safe method to locate underground utilities? Is using hydro vacuum equipment acceptable?
Okay, that is a great question. So I'm going to begin with the first. What is a safe method to locate underground utilities? As a general rule, the safest and most common form is hand digging with a shovel to expose the utilities that you're targeting. Depending on the type of utility and the estimated depth of the utility, other forms use a locator probe, ground sonar, and the second part of your question is the growing form of the hydro excavation. So my answer is yes, hydrovac is an acceptable form of locating underground utilities. It does apply to MIOSHA standards when it comes to excavation. We have to be conscious of what type of utility are we trying to expose also. So, if we have a utility that's 5 feet deep or 4 feet deep with a water line, we can't just go straight down with a vac truck and just leave it exposed. So that's definitely a good question. And so those are the best ways to locate.
Okay, thank you very much. We're going to move on to our next question. And our answerer will be Mr. Greg Brooks. Greg, can you hear us okay?
I can, thank you.
Okay. Well, the question that I have for you, Greg, is how do I properly inspect an excavation?
That's a great question, and often, kind of an overlooked aspect of excavation. First of all, we should mention it's the designated qualified persons responsible for inspecting an excavation. And then as far as when, MIOSHA standards require an ongoing inspection of the excavation. So I need to talk a little bit about what ongoing means. Basically, an inspection should be performed at the beginning of every shift or whenever employees enter an excavation, and then after every rainstorm or any other hazard-producing occurrence. And then whenever there's a condition or a situation change, like a depth change or a soil type change. As far as how to inspect the excavation, several things that we need to take a look at here. First, take a look at the surface conditions. Ensure there are no cracks along the top edge of the excavation. Make sure your spoil piles, your materials, and your equipment are not within 2 feet of the edge of the excavation. And then finally, ensure there are no sources of vibration around the excavation. After you check the surface conditions, the qualified person is going to want to check the banks or the sides of the excavation. Check to make sure there are no cracks in the walls of the excavation or the trench. Look for soil falling from the sides of the excavation. Ensure there's been no changes in the soil type and that your slope remains adequate for the class of soil that was originally selected. And if you're using shoring, shielding, you want to double check your shoring and shielding. Make sure it's still in place, still effective. Take a look at your hydraulic cylinders. Make sure they're not leaking and that your wedges remain tight. And lastly, you want to take a look at your access and your egress. Make sure your ladders, your ramps that you're using for access or egress are in place and remain compliant.
Okay, fantastic. This sounds like something that is definitely not a do-it-yourself type of task. So thank you so much for that great information. The next question goes to Tracy Alfonsi. Tracy, who determines a qualified person?
Thanks, Jerry. So both Jeremy and Greg referenced qualified person. So let me start first with defining what that means, and then I'll kind of break that down into how they're selected and who's responsible for selecting. So according to the definition in Part 9, a qualified person is a person who, by possession of a recognized degree or certificate of professional standing, or who by extensive knowledge, training, and experience has successfully demonstrated the ability to solve or resolve problems relating to the subject matter and work. So basically what that means is that the employer is ultimately responsible for identifying a qualified person. And they do that by evaluating two basic criteria. The first one is, has the individual received training specific to the equipment or task involved? And the second part, which I think is the most important part, is can that person demonstrate skills and knowledge to solve or resolve problems specific to the work? So yes, they took a class, or yes, they got a certification, but can they then apply that knowledge in an actual job environment and make decisions that are going to keep the work crew safe? So in some cases, a degree or certification may be required as part of a qualification, like an engineer, for example, or in other cases, it may involve a combination of tenure and training. In addition, you may have one individual qualified to design the trench support system and an entirely different qualified person responsible for those ongoing inspections that we just talked about in the last question. So said differently, the employer determines the qualified person, and it's based on a combination of their prior work experience and training they've received specific to the work.
Thank you, Tracy. Will Pitlack? I've heard of the 2-4-5 rules. What are those?
Okay, so referring to the 2-4-5 rule, these are the beginning basics of trench safety. The 2 applies to keeping all overburden, debris, and spoils a minimum of 2 feet away from the final side slope of the excavation. This prevents overloading the banks with excessive weight, and should a piece of overburden begin to roll down the pile, it creates a landing bench to prevent the piece from falling into the excavation. This also helps maintain a safe, flat means of egress along the trench. Another great benefit is this allows crew members to see any cracks or movement along the slopes or sidewalls, indicating a possible trench collapse. This brings us to the 4 in our sequence. This rule applies to trenches 4 feet in depth. A ladder must be within 25 feet of a crew member in the trench at all times. The ladder must extend 3 feet above the top of the trench and maintain a clear and fast exit for crew members. A proper ramp can be used for access and egress in place of a ladder as well. Last but not least, we're on to the 5 in our 2-4-5 rule. This is very simple and straightforward. Any trench that is 5 feet deep must be properly shored, sloped, benched, or shielded with something like a trench box.
Very cool. I mean, a 2-4-5 might not win me anything in the pick 3, but if I follow that in trenching and excavation, it could keep me alive. So let's move on to our next question and our next answerer, and that's Mr. Greg Brooks. So Greg, is water allowed to be present in an excavation while employees are inside?
Oh, thanks, Sherry. This is a very common question that comes up here in the state of Michigan, and quite frankly, it's a real straightforward answer. In fact, I'm just gonna quote Part 9, Rule 932, Paragraph 2 and 3 for you. An employee shall not work in an excavation in which there is accumulated water or in which water is accumulating unless precautions have been taken to protect employees against the hazards posed by water accumulation. The precautions necessary to protect employees adequately vary with each situation, but may include support or shield systems to protect from cave-ins, water removal to control the level of accumulating water, or the use of a safety harness and lifeline. And if water is controlled or prevented from accumulating by the use of water removal equipment, the water removal equipment in operation shall be monitored by a qualified person or a monitoring system to ensure that the equipment is properly operated. So basically, accumulated or accumulating water can create a very significant cave-in hazard. So before an employee can enter that excavation, precautions need to be taken to remove the water and protect the employee from a cave-in.
Thank you, Greg. Our next question goes to Paul Rosinski. Paul, how does MyOSHA classify soils, and is it different from OSHA?
Okay, thank you, Chair, Sherry. Excuse me. So yes, MIOSHA in their regulation actually uses table 1. And that not only represents the angle of repose for sloping, but it gives us a lot of good information regarding the types of soils that we would encounter. So this table uses the unconfined compressive strength when you measure it with a pentometer, and that is much like the federal OSHA does. Federal OSHA separates their soils into categories of A, B, and C, which is a little different from how MIOSHA does, because they refer to the tons per square foot over the compressive strength of that soil in determining what the proper slopes are. So that competent person has to really know a lot of things about the soil and what they encounter. Both MIOSHA and OSHA also provide examples of soil types within their regulation. And MIOSHA even provides information on soil types in the definition of their regulation as well. Other considerations that would need to be taken into account would be, water content. Has the area been previously excavated? Are there utilities present? How about obstructions? And then the length of time that the excavation has been exposed, and that means or open, to any environmental impacts. That would be either if it's dried out or if it's rained or become saturated. And then any freeze-thaw events that could have an impact on the soil as well, especially in the winter conditions that we work here in Michigan in. So there's a lot of information that's available for that competent person to look at the types of soil, even such simple things as a simple roll test in your hands, and even going as far as even putting the soil in water and doing a sediment test can also help determine exactly what types of soil you have.
Thank you very much, Bob. Okay, our next question will go to Mr. Chris Smith. Chris, our question to you. How do we determine soil classification? What means can we use?
Hey, thanks, Sherry. Knowing the soil classification is critical for sloping and benching in excavation. So Part 9 has Table 1. It's a great tool, and it visually displays the 8 different types of soils we have in Michigan. There are many means of testing the soil, but some of the most common are, like Paul said, pocket penetrometers. So that's it's designed, it's a spring instrument. It's designed to be pushed against the soil, and it has a sleeve that'll display the reading. And most instruments are calibrated tons per square foot. So you can get that and then follow up with Table 1. Another testing is a thumb penetration. So that involves pressing your thumb firmly against the soil, and based on how far your thumb goes into the soil, that'll determine what classification the soil may be. Another test is a visual test, and that's just overall visual of the site, the entire excavation, adjacent sites, as well as using possible soil borings if you have them, to give you a clear description of what is in that soil and what's underneath the ground. Another test, like Paul mentioned, is a ribbon test or a wet thread. So that's when you have a moist soil, roll it into a small ball, and then kind of roll it out into your hands, into similar to like a hot dog. And it's gonna, depending on how the cohesiveness of it is going to determine the classification of the soil. With all the different soil types in Michigan that we have, and all the different testing measures, it's really important that we're doing ongoing inspections of the excavation. and these are all made by a qualified person. So, and these inspections need to happen continuously throughout the day. That's probably the most important piece, because as weather's changing, so can the excavation.
Okay, thank you very much. Tracy Alfonsi. Do I need fall protection while working around an excavation?
So there are two scenarios when fall protection would be required around an excavation. The first is when there's an obstruction or a barrier that hides the excavation or trench from plain view. Commonly outside, we're dealing with landscaping, bushes or trees that are obstructing the view. So if somebody could stumble upon an excavation without realizing it was there, then a barrier, or I'm sorry, to comply with the rule, you would need to erect a barricade around the excavation or cover over the excavation with something strong enough to withstand anybody walking over it. The second scenario is when workers are using a bridge or a walkway or a ramp that they've placed across the open excavation. And in that case, a guardrail system would be required. When feasible, however, it is considered best practice to control fall hazards, including using a protective railing system that clips onto the shoring box to protect workers if it's a crowded area. Opportunity to provide fall protection, then that's always welcomed. But the two situations where it's required are on a ramp or a bridge over the top of an excavation or when it's obstructed from view.
Thank you so much. Paul Rosinski. When should I conduct atmospheric testing and how often should that take place?
Well, there's a lot that goes into making that determination. One of those things could be, were there any pre-existing or hazards that were associated with the atmosphere in an excavation? So if I know I'm working around a site that maybe had hazardous materials that were stored in a tank or underground gas storage or anything else, we have to make sure that the atmosphere is okay for anybody to enter into that excavation. So prior to entering into that, doing my research, finding out if there's any pre-existing conditions, we need to make sure that, is there an oxygen deficiency or a hazardous atmosphere that exists? If we do, that would need to be done prior to anybody entering the excavation, or even prior to installing any alternative methods that you would be using to stabilize that atmosphere that those people would be entering into that. If there was a hazardous substance stored nearby, the atmosphere in that excavation has to be tested when they're at 4 feet deep, no more than 4 feet deep. Most common practice that is used is 4 gas meters, and they use those as a continuous monitor in conjunction with testing before those employees go in that excavation to their work. So it is very important that you do your homework and you find out the history about where you're doing the excavating. Even if there's gas lines that run through there, the mercaptan gives us a good information about if there's a leak. We can smell that, but others, other hazardous impact on those excavations might not be readily identifiable like that. So it's best practice to use a 4 gas meter if there's a question or a possibility that you could have a hazardous atmosphere for continual monitoring.
Okay, thank you very much, Paul. Chris Smith, does the trench shield or shoring information need to be on site?
Yeah, good question, Sherry. Yes, it does. So the supporting system shall be designed by a qualified person, and that design of the supporting system shall be maintained on the job site, and any changes from that design must also be approved by a qualified person. You can't make up your own shoring system unless you're a qualified person. So if these are on site, make sure you have that in your trailer, your gang box, in the foreman's truck, and you have it available.
Okay, Thank you. We've had some great questions and lots of great answers, very thought-provoking information, clarifying information. And I'm going to turn it back over to Jeremy Hidalgo, who's going to close us out today.
Thank you, Sherry. As we conclude today, we hope you have benefited from this presentation, and we will be able to further discussions with your employees to reinforce the importance of trench safety. We would again like to thank all our participants for their expertise and the time they have dedicated to providing answers to these excavation questions. Going forward, you can find more information about MIOSHA's excavation emphasis program, Slope It, Short, Shield It, at www.michigan.gov/MIOSHA trenching. At that website, you can also find lots of helpful information about excavation safety, as well as today's program. OSHA has also an interactive website with trenching and excavation information. Also, please remember MIOSHA is available to provide training and resources to all contractors who would like assistance. Contact MIOSHA CET Division with questions, training needs, or to schedule Michigan Training Institute courses at 517-284-7720. The Enforcement Division is also available to answer standard questions. Thank you and have a safe day.